Welcome back to the Deep Dive.
Great to be here.
Today, we are really digging into something fundamental. We're talking about the core tools that give you control in Azure.
Absolutely. The real building blocks.
We're going deep on Azure governance, specifically, management groups, Azure policy, and of course, resource locks.
And it's just such foundational material. I mean, if you're managing any kind of serious Azure setup
We're studying for the AZ-104.
Exactly. Or if you're prepping for that AZ-104 exam, you have to know this inside and out. It's not optional.
So our mission today isn't just a definition dump.
No, not at all. We want to pull out the tricky parts, the little details, and the gotchas that really matter when you're in the trenches trying to build a framework that's scalable and secure.
We've got a whole bunch of real-world scenarios lined up to help with that, and we're going to frame it around 3 pillars. First up is hierarchy, which is all about management groups. Then we'll get into the guardrails with Azure policy. And finally, we'll talk about immutability, which is where resource locks come in.
And we're really going to hit hard on those common wrong assumptions. If you understand why a policy can override an owner or exactly when you should reach for a lock instead of a policy, that's when you move from just knowing the tools to mastering them.
Okay, let's do it. Let's start at the very top with the foundation. Management group architecture.
Perfect.
All right, scenario 1 kicks us off, and it's a classic problem. We've got a global company. They have operations in the Americas, EMEA, APAC. They've got prod and non-prod environments.
And good stuff so far.
Right. But they also need cost visibility. Why? Department of Finance, HR, engineering. So you've got this mix of governance needs and financial reporting needs.
And this is the perfect test. It immediately forces you to decide what management groups are for. The common trap, the wrong assumption, is to look at that list and immediately start building your MG tree based on the org chart.
So you mean creating a management group for finance, one for HR, and so on?
Exactly, because that's where the cost centers are, that's who pays the bills. It feels intuitive.
But why is that a trap? It sounds logical on the surface.
Because you're optimizing for the wrong thing. Management groups exist for one primary reason: policy inheritance. They create a rigid hierarchy for rules to flow down.
Okay.
So think it through. If you have a finance MG and that team needs a new production subscription in Europe, that subscription now inherits policies designed for the finance department, not for a regulated production workload in an EMEA region.
I see. So you might be missing critical GDPR policies, for instance, because the MG is organized by department, not by region.
Precisely. Governance has to flow down the tree. And the things that dictate your governance rules are almost always your region for regulatory reasons and your environment for security reasons.
That makes sense. Production is always going to be stricter than development, regardless of which department owns the app.
Always. So the correct approach, the one that sets you up for success, is to build the MG tree based on what drives those policy differences.
So walk me through what that would look like.
You'd start at your tenant root. Then your first level would be your major regions, so Americas, EMEA.
Okay.
Underneath each of those, you'd break it down by environment. So you'd have America's prod and America's non-prod.
And with that structure, I could apply my GDPR policies at the EMEA level, and they just cascade down to every single subscription in that region.
Exactly. And you can apply your super strict security baseline, like mandatory encryption, at all the DIC prod MGs.
Right.
So now, any subscription that gets put into a production MG instantly gets those ironclad rules. It doesn't matter if it's for finance or engineering.
Okay, that solves the governance problem beautifully. But what about the other half of the requirement? How do we give the finance department visibility into what they're spending?
And that's where the other tool comes in. This is the critical distinction: tags.
Ah, right.
Tags are for flexible, non-hierarchical metadata. Cost centers, application owners, department names. That stuff is perfect for tags.
So you tag every resource with something like Department Finance.
You got it. Then Azure Cost Management can slice and dice the billing data based on that tag. Finance gets the report, and you haven't broken your entire governance structure to do it.
So MGs are for the rigid hierarchy of rules. Tags are for flexible reporting.
That's the key takeaway. Don't mix them up. The exam will definitely test you on knowing which tool to use for which job.
Let's build on that with scenario 14. We have this perfect MG structure now. How do we make sure new subscriptions actually land in the right place and are compliant from day one? We're talking about automating subscription onboarding.
Yeah, this is all about avoiding what I call the governance race condition.
What's that?
It's what happens when you let a developer just click create subscription in the portal.
Okay.
There's a gap, a time gap between when the subscription exists and when your governance team can manually go in, move it to the right MG, and apply all the necessary policies.
And in that gap, the developer could deploy a bunch of non-compliant stuff, like a storage account with public access.
Exactly. The non-compliant resource is already there before the guardrails are up. You're already behind.
So the right way has to be automated.
It has to be. You need a centralized, automated process for subscription creation. Using infrastructure as code is the way.
So we're talking ARM templates, Bicep.
Bicep is the modern choice, but yes. The key is that this automated process does a few things immediately. First, and most importantly, it places the new subscription under the correct management group at the moment of creation.
You can specify that during the creation process.
You can. It's a property in the deployment. So from the first second of its life, it inherits all the right policies from its parent MG. The race condition is gone.
That's huge. What else should that automation do?
It should also lay down the initial structure, maybe create some mandatory resource groups, apply the necessary billing tags.
And maybe even a lock.
You could absolutely apply a temporary cannot delete lock on some core networking components until the app team is ready to take over.
So it's about preemptive governance, not reactive cleanup. You build compliance in from the start.
That's the only way to scale. If you're manually cleaning up non-compliance, you've already lost.
Okay, with that MG foundation set, let's talk about the guardrails themselves. Let's get into Azure policy.
Let's do it.
Scenario 2 is a great starting point because it deals with a very real fear. We need to implement a tough policy, say, no public IPs on VMs, but we have a huge existing environment and we're terrified of breaking something.
This is a test of process maturity. Do you understand the safe policy life cycle, which is audit, fixie, deny?
And the big mistake is just jumping straight to deny.
Oh, yeah. Assigning a restrictive policy with the deny effect at a high scope, like the root MG, is a recipe for a very bad day.
Why is it so risky, though? I mean, doesn't it just stop people from creating new bad things?
It does, but it does more than that. A deny policy also blocks updates to existing resources if that update would make them non-compliant. You could suddenly block your operational tools from patching a VM or prevent a critical fix from being deployed because it touches a configuration that the new policy now forbids. You can lock yourself out.
Okay, that's bad. So what does the safe, responsible approach look like?
You always start with audit. You assign the exact same policy, but you set the effect to audit.
And you'd probably start with a smaller scope, right? Like a non-prod environment.
Absolutely. Start small. The key thing about audit mode is that it's completely passive. It blocks nothing. It's purely a reporting tool.
It's like a compliance report card. It tells you how big your problem is before you flip the enforcement switch.
That's a perfect way to put it. You review those audit reports, you see every resource that's out of compliance, then you go through the remediation phase. You work with the teams to fix the issues, remove those public IPs, reconfigure things properly.
And only when that audit report looks clean, or at least acceptable, do you even think about enforcement.
Exactly. And even then, you roll out the deny effect cautiously. Start in non-prod, watch it for a week, then move to prod. Deny is the final step, not the first.
That makes a lot of sense. So let's talk about some specific use cases. Scenario 6 is about restricting things like VM sizes to control costs.
Right. You don't want someone spinning up a massive, expensive GPU-enabled VM by accident for a simple web server.
So how do we handle that with policy?
The good news is, for common things like this, you don't need to write custom policies. Azure has a library of built-in ones, like allowed virtual machine SKUs. The key is to use parameterization when you assign it.
What does that mean in this context?
It means when you assign the policy, you provide it with a list of the approved VM sizes, the parameters. You might say, only SKUs from the DSV3 family are allowed.
And you assign that at a high-level MG.
Right. So you have central control over your cost and performance standards across the entire organization.
So that's how we restrict what can be deployed. But what about scenario 11? This is about making sure a baseline is actually deployed. For example, ensuring every VM has the monitoring agent installed or that Azure Defender is enabled on all subscriptions. Audit just tells you it's missing.
And deny would just block the VM from being created if the agent isn't there, which isn't helpful.
Right. Neither one actually fixes the problem.
And this is where you need to know about a really powerful policy effect. Deploy if no exists. or DINE for short.
Okay, let's break down DINE. How does that work?
DINE is really cool. It has two parts. First, it checks for a condition, just like any other policy. For example, was a new virtual machine just created? If that's true, it then checks for the existence of a related configuration. Does this new VM have the monitoring agent extension?
And if it doesn't?
If it doesn't, DINE triggers a nested ARM template deployment.
So the policy itself kicks off a deployment to fix the non-compliance.
Yes. It automatically deploys the missing agent or configures the diagnostic settings or whatever you've defined in that template. It's auto-remediation.
That seems incredibly powerful. Is there a catch?
The main thing to remember is that this deployment is done by a managed identity. You have to grant that identity the right permissions, usually contributor, at the scope where the policy is assigned so it can actually create or modify resources.
And it's probably not instantaneous, right? Since it's a separate deployment.
That's a great point. It's asynchronous. It kicks off a deployment in the background, so there's a small delay before the resource is fully compliant. But for ensuring baselines are in place, it is absolutely the tool for the job.
All right, let's get into the tricky stuff. The policy traps.
The fun stuff.
Section 3, Scenario 4. The surprise of inheritance. A team moves their subscription from a relaxed sandbox MG to the super strict prod MG. And immediately, all their deployments start failing.
The first call they make is to the identity team. My permissions are broken. My owner role is gone.
But it has nothing to do with RBAC.
Nothing at all. It's all about policy inheritance. When you move that subscription, you are instantly changing the entire set of rules that apply to it.
It's like moving your house from a town with no building codes to one with the strictest codes in the country.
Perfect analogy. The prod MG has a whole stack of deny policies that the sandbox MG didn't. No public IPs, only certain VM sizes allowed, mandatory private endpoints. The subscription now inherits all of that, and their old deployment scripts are now trying to build things that are forbidden.
So what's the fix? How do you diagnose and solve this?
First, you check the policy compliance blade for that subscription to see which inherited policy is causing the block. Then, if there's a legitimate reason for an exception, you use an exemption.
Talk about exemptions. How are they different from an exclusion?
An exclusion is part of the initial assignment. You say, apply this policy to the whole subscription, but exclude this one resource group. An exemption is a separate object you create later. It's a formal, auditable way to say, I know this policy exists, but for this specific resource, for this specific reason, and maybe until this specific date, we need to bypass it.
So it's a more granular and time-bound way to handle exceptions?
Exactly. It's a critical tool for managing migrations or special cases without weakening the overall policy.
This leads perfectly into the ultimate precedence nightmare, Scenario 7. A user is an owner on a subscription, the highest possible role.
Yep.
And they're still blocked from deploying something. The error message specifically says, deny assignment.
This is probably the single most important concept about the ARM control plane an administrator can learn. The owner role is not absolute.
Why not? I mean, owner sounds like it should be able to do anything.
It sounds like it, but the Azure Resource Manager evaluates access in a very specific order, and it checks for things like resource locks and policy deny assignments before it even looks at your RBAC role.
So the policy check comes first.
It comes first. Think of it this way. RBAC gives you the keys to the building. The owner role is the master key. But a policy deny assignment is a steel door that has been bolted shut by a higher authority. It doesn't matter what key you have, you are not getting through that door.
That's a great way to put it. So it's a fundamental design choice to prioritize governance over individual permissions.
Precisely. It prevents a rogue or compromised owner account from dismantling the security and compliance structure that the central team put in place. It's a critical safeguard.
So if you're an owner and you're blocked, granting yourself more permissions is pointless.
Completely pointless. There's no higher role. You have to go to the source of the denial, the Azure policy assignment.
And create an exemption.
You find the policy causing the deny assignment, and you create a targeted exemption for the resource or user that needs it. That is the only way forward.
Okay, let's switch to troubleshooting. Scenario 8. A policy just doesn't seem to be working. You've assigned a policy to enforce encryption on storage accounts, but you keep seeing unencrypted ones pop up.
This is when you have to go back to basics. The policy engine itself is rarely broken. It's almost always a configuration issue. There are 3 things to check.
I'm guessing number 1 is scope.
Number 1 is always scope. Is the policy actually assigned where you think it is? Did you assign it to the prod MG, but the team is deploying into a subscription that's still under the dev MG? The policy will never see it.
Check 1. What's check 2?
The effect. This goes back to our life cycle discussion. Did you mean to block creation, but you actually set the effect to audit?
Ah, so it's correctly flagging it as non-compliant, but it's not actually stopping anyone.
Right.
Yeah.
Audit will report, but it will not block. You need deny for that. Make sure the effect matches your intent.
And the third check.
Evaluation timing. Remember, policy is enforced on new resources in real time during deployment. But for existing resources, it relies on a background compliance scan.
And that can take a while.
It can take hours. So if you're looking at an existing resource, you might need to be patient for the compliance state to update.
Okay, final policy trap, scenario 15. This one is about exclusion logic. A policy is assigned at a subscription, and you carefully add an exclusion for one specific resource group. But the team, using that RG, is still blocked.
This is the scoped collision trap. The incorrect assumption is that an exclusion is a global get-out-of-jail-free card.
But it's not.
It is not. An exclusion is specific to that one single assignment.
So if they're still blocked, even with a local exclusion, what's happening?
It means there's another assignment of the same policy coming from a higher scope that doesn't have that exclusion.
So like from the management group above the subscription.
That's the most common culprit. The MG has a broad policy to deny something, and that assignment doesn't know or care about the little exclusion you added way down at the subscription level. The inherited deny from the MG still applies.
So you have to trace the policy all the way up the hierarchy.
All the way to the root, if necessary. You have to find every assignment of that policy that applies to your scope and make sure they all have the required exclusion. It's a lesson in how powerful inheritance is.
Okay, that covers the nuances of policy. Let's move on to the hard line. Resource locks.
The sledgehammer of governance.
Exactly. Scenario 3 sets it up perfectly. We have a mission-critical resource group. It's got our hub VNet, our central firewall. It cannot be deleted, not even by an owner having a bad day.
This is the definitive test of when to use a lock versus a policy. The wrong way is to try and write a complex Azure policy to deny the delete operation.
Why is that the wrong tool for this job?
Because of their fundamental purpose, Azure policy is about enforcing the configuration of a resource. Is it encrypted? Does it have the right tags? Is it the right size? Resource locks operate at a lower level, at the ARM layer. They don't care about configuration. They care about blocking entire operations like delete or write before anything else happens.
So for pure deletion protection, a lock is the purpose-built tool.
It's the only right answer. You apply a cannot delete lock to that resource group, and ARM will reject any delete request, period. It doesn't matter if it comes from an owner, a script, anything.
The lock protects the existence of the resource.
And policy protects the compliance of its configuration. Knowing that distinction is vital.
Let's talk more about the severity of locks, especially the read-only lock. Scenario 5 is a horror story. Someone puts a read-only lock on an RG that has an active web app, and suddenly everything breaks. Deployments fail, scaling fails, config changes fail.
This is a catastrophic misunderstanding of what read-only means. People think it just means cannot delete plus a bit more.
They think it just prevents deletion but allows updates.
That is fundamentally wrong, and it's a painful lesson to learn in production.
So what does read-only actually block?
It blocks all write operations. In ARM terms, that means it blocks PuT, post, and delete.
Okay, delete is obvious. What about PuT and post?
A PuT operation is what you use to update a resource or deploy new code. A PuST is used for actions like restarting a VM or triggering a scaling event.
So if you block all three, you've basically frozen that resource in carbonite.
You've created a static museum exhibit. Nothing can change. For an active workload like a web app, a read-only lock is a death sentence to its operations.
It's way too extreme.
Way too extreme for most things. But then you have scenario 12, which is the one time it's the perfect tool.
Right, this is for an audit scenario. A subscription holds regulated data. The rule is no new resources, no changes, no deletions. But auditors need to be able to see everything.
Now that absolute freeze is exactly what you want.
So you apply the read-only lock at the subscription level.
You do. That enforces the no modifications rule at the ARM level. And then you use RBAC to grant the auditors the reader role, which gives them the visibility they need. The two tools work together perfectly to meet that specific requirement.
So read-only is for when you truly mean archive this and don't touch it.
That's its job.
Let's look at one last combination, scenario 10. We have a shared RG with base VM images. We never want them deleted, but a CI/CD pipeline needs to be able to update them with new patches.
This is a great example of layering your controls. You need deletion protection, but also controlled updates.
So step one for no deletions is obviously the lock.
Yep. Apply a cannot delete lock on the resource group. That handles the protection against human error from anyone, even an owner.
But that lock still allows PUT and POST operations, the updates. How do we make sure only the automated pipeline can perform those updates?
That's where you bring in RBAC for fine-grained control over the allowed operations.
So you restrict who has contributor rights?
Exactly. You make sure that the only identity with contributor permissions on that specific resource group is the service principal for your deployment pipeline.
And you remove that permission from all human users.
You got it. So now the lock prevents what can be done, no deletion. And RBAC controls who can do the remaining actions. Only the pipeline can update. It's a perfect partnership.
That's a really solid pattern. Okay, let's move to our last section. Protecting the governance framework itself.
Super important.
Scenario 9 is about controlling who can manage policies. We need a central governance team to be the only ones who can create or change policies. We can't have app teams creating their own rules that conflict with the central ones.
If you don't lock this down, your entire governance structure can be undermined from within. An app team could just create an exemption for themselves for every restrictive policy you make.
And the common mistake is just giving app teams owner on their subscriptions because it seems easier.
Easier, but it completely breaks the model. Policy creation is a privileged operation. You have to use specific roles to separate duties.
So what's a correct role setup?
Your central governance team needs the resource policy contributor role at the MG or subscription scope. That's the purpose-built role for managing policies.
And the app teams?
The app teams should only have contributor at the resource group level. That lets them build their apps, deploy resources, do their job, but they have no policy rights at the higher scope.
So you separate the rule makers from the rule followers.
It's a fundamental principle of good governance. The people operating within the system shouldn't be able to change the rules of the system.
Makes perfect sense. Okay, last scenario, number 13. This brings us full circle, back to tailoring governance for different environments. A dev subscription needs some freedom to experiment, but it still needs basic guardrails like tagging. Prod needs to be locked down tight.
This is a test of using the MG hierarchy intelligently. The trap is to create one giant policy initiative and apply it everywhere.
Which would either stifle developers or leave production dangerously exposed.
One of those two, yes. The right way is to create multiple layered initiatives.
So 2 different sets of policies.
At least 2. You'd create a baseline initiative. This has the bare minimums that apply to everyone, mandatory tagging for cost tracking, maybe a block on the most insecure configurations.
And then a second, stricter one.
Right. A strict initiative. This is where you put all your production-grade controls. Very narrow lists of allowed VMCUs, a hard ban on public endpoints, specific regulatory controls.
And then you use the MG structure to apply them.
That's the key. You assign the baseline initiative at a high-level MG that covers both dev and prod, so everyone gets the basics. But you assign the strict initiative only at the specific prod MGs.
That's elegant. So dev just inherits the baseline and has freedom, while prod inherits the baseline plus all the strict controls.
Exactly. You're using the hierarchy for its intended purpose, to apply layered, context-appropriate governance. It's the hallmark of a well-designed Azure environment.
And it all goes back to that very first scenario, designing your MGs around region and environment to enable this kind of tailored control.
It all connects.
This has been a really critical deep dive. We've hit some really specific points that honestly can make or break an Azure environment. Let's just quickly run through the absolute key differentiators one last time.
Let's do it. First, management groups are for policy inheritance. Use them for things like region and environment. For cost tracking, use tags.
When you're rolling out a new restrictive policy, the mantra is audit first, deny later.
And if you need to automatically install baselines like monitoring agents, the tool for that is the deploy if no exists effect.
This one's huge. A policy deny assignment beats all RBAC roles. Even owner. If an owner is blocked, look for a policy.
And finally, the locks. Cannot delete is for deletion protection. The read-only lock is an absolute freeze. It blocks updates, scaling, everything. Use it with extreme caution.
Getting those distinctions right is what really separates a junior admin from an expert.
It absolutely is. And, since we established that a policy deny assignment is so powerful it can even override an owner, it brings up a final question for you to think about. If every normal user, even an owner, is subject to these policies, what about a true emergency, a break glass scenario? What kind of special security principle, if any, should be exempt from all governance controls for that break glass access? And more importantly, how would you configure that access without completely destroying the principle of least privilege?
That's a tough one. Just connects all this architecture to the messy reality of privileged access management.
And it does, something to chew on.
A great thought to end on. Thank you for joining us for this deep dive into Azure governance. We'll catch you next time.